Okay, so problem. We have an equilibrium mixture of N2, O2, and NO, gases at 1500 Kelvin, is determined to consist of, we have this N2, we have 1.7 times 10 to the negative third moles per liter of oxygen, and 1.1 moles per liter of NO. What is K? All right, so K is products over reactants. All right, so let's fill this in. The product is NO. The reactants are O2 and N2. And if you're wondering where that 2 came from, remember the coefficient gets moved over to the exponent there. Okay, now all we need to do is plug in some numbers for this. So let's plug in the number for NO. That is right here, 1.1 times 10 to the negative fifth. And moles per liter, so it's going to be big M. And then we have O2. O2 is 1.7 times 10 to the negative third, big M, times N2, which is 6.4, times 10 to the negative third, big M. All right, and we can't forget the exponents, right? So if you check this out, you see that the 2 is there, so we need the 2 to be here as well. So there's a few ways to put this in your calculator. One way would be to actually put parentheses around the 1.1 times 10 to the negative fifth, because then you can just put the little caret and then 2 to raise it up there. Or you can just put 1.1 times 10 to the negative fifth in your calculator, hit enter, and then raise it to the second power. However you want to do it is fine, as long as you're, following the laws of math. So take a minute, let's make sure we can plug this in our calculator, and then we'll... Okay, so the first part of putting this in your calculator is that 1.1 times 10 to the negative fifth squared. So when you do that, you put it in the calculator, it'll probably look something like this, and then you'll get 1.21 times 10 to the negative 10. Once you have that, that's the top part. So then you divide by this, and then you should get, with 2 sig figs, right? 2 sig figs, 1.1 times 10 to the negative fifth, and that would be it. That would be what K is. So the next question is, okay, is this a large K or is this a small K? Well, is that number larger or smaller than 1? Well, it's 1.1, but it's to the negative fifth, right? So that is much smaller than 1. So because that is smaller than 1, so K is less than 1, that means that when this goes to equilibrium, this equation right here goes to equilibrium, you're going to have more of the reactants and you're going to have less of the products. So even though in everything that we've learned so far has always been like, oh, you take your reactants, you make your products. In this case, we're still going to have a lot of these reactants, and then we'll have some of this product formed at the end of the reaction. So that's what equilibrium kind of shows us. It's when there's reversible reactions, if we're going to have more products or we're going to have more reactants. And in this case, because K is less than 1, we're going to have less products. We're going to have more reactants.